Good afternoon, everyone. My topic is on design and development of Neopixel-based smart wireless fitness training system. My co-author and guide both are Mr. Vikram Atrayavi, who is a assistant professor, Department of Mechanical Engineering, NIE Mysore. Fitness is the condition of being physically fit and healthy, which includes various sports activities and gym activities. These activities help to develop coordination between mind and body, and in turn helping to avoid health problems. Hence, the proposed system focuses mainly on design and development of fitness training system called as FitLite. And this FitLite is a unique wireless reaction training system comprised of time of flight LiDAR sensor and WS2812B model RGB LEDs, that is called as Neopixel, and battery charging circuit, and ESP Room 32 microcontroller unit as hardware, and ESP protocol Bluetooth embedded CS software. And this FitLite is used as target for users to deactivate NeoPixels and can be adapted to all sports and training regimes. And it captures the data and provides feedback via IoT cloud platform. In recent times, so many people are facing health problems, maybe because of adulterated or unhealthy food habits or busy work life, and mainly of overeating and no proper diet followed. And as the saying, there is a saying that health is neither an invention nor an idea, and an proverb, health is a wealth. So if the body and mind are well exercised, then every human being can lead a healthy lifestyle. So physical fitness is a state of health and well-being, and this can be defined in two categories: health-related and motor-related. Health-related components are of great importance because they make an individual fit and productive for everyday living, whereas motor-related components make an individual successful in athletics or motor-related activities. So there are conventional training sessions uses barbells, dumbbells, and machines, and many other equipments, which basically does not track the workout data. And to track the workout data, there are many modern fitness sensors used in fitness tracking smartwatches. To name a few, and which are majorly used in many tracking smartwatches, are 3-axis accelerometer, gyroscope, and altimeter. The 3-axis accelerometer is used to track movement in every direction. An accelerometer sensor takes inertial measurements of velocity, position, and usually on 3-axis, it can sense inclination and orientation of body as well. But its efficiency degrades over time, and it has less longevity and hysteresis error. So coming to gyroscope is used to measure orientation and rotation. A gyroscope can be used for navigation and measurement of angular velocity. A 3-axis gyroscope can be paired up with 3-axis accelerometer to provide a 6 degree of freedom motion tracking system. But a free moving gyroscope type is always dependent on a rotation of Earth, and hence it does not measure linear motion in any direction. An altimeter is used for altitude measurement for mountain climbing, hiking, trekking, etc. Most fitness enthusiasts may not offer an altimeter unless the individual opt for one specifically designed for mountain climbing, trekking, hiking, etc. And hence, instead of all these three sensors, we have used a LiDAR sensor, which is an acronym for light detection and ranging. So LiDAR uses laser pulses that travel at the speed of light, and hence enabling to collect data fast and accurately. And coming to the RTM designer, it is a PCB designer software used to design a PCB, and which is used in our work. And after designing the PCB, the firmware integrating it with the firmware tracking the workout data is essential. Hence, IoT cloud platform should be included, which was included. And now the objective was to design and develop an embedded based fitness training system with low cost and low power consumption. And hence, to meet our objectives, the initial stage is to give the overview of work, and next stage is to explain the design of fitness system, and next is to do the PCB designing, and finally developing the system and discussing the end results. So this is the block diagram or implementation of the fitness system, or the design of the fitness system. As previously discussed, it consists of battery to make it wireless, where battery charging circuit, and then my microcontroller unit and LiDAR sensor. And there is one master FitLite and 3 or 4 slave FitLites. The master FitLite is communicated with a mobile through Bluetooth, and the master FitLite is communicated again through the slave FitLites through Wi-Fi, and then the data is sent to the cloud. And this is the schematic design done in LTM for the battery charging circuit and the Neopixel. And this is the schematic design done for the VSP Vroom microcontroller unit. And this is the layout design done, overall layout design done. And routing is done for the flow of electrons. And this is the 3D view of the FitLight board. So, and after the design phase is done, the development phase includes the ESP-NO protocol. So ESP-NO protocol is a connectionless communication protocol that is defined by Expressive. Application data is encapsulated in a vendor-specific frame and then transmitted from one Wi-Fi device to the another Wi-Fi device, and it has a unique MAC address for communication between the master and slave. And the embedded, this protocol is used broadly across the globe for Wi-Fi, ESP Wi-Fi boards. And embedded C programming was used to read the code, where a functionality testing process was done initially to test the hardware part, and then etching process before sending the PCB to the manufacturing and assembly. The etching process is done to ensure that designed PCB is working properly. And final working FitLight is done after the manufacturing and assembly. And then pre-programmed drills is the designed by us, where yes or no drill and focus upon same and different color drills is the name given by us. Yes or no drill focuses mainly on the user, where the instructor gives instructs based on the instructor, the user have to deactivate the FitLight board. Yes resembles green color and no resembles red color. And focus upon same and different colors drill is the user will be standing at some far distance from the FitLight boards. Then you will run towards it based on the instructor's advice, and then you have to deactivate the same or different colors based on his advice. And then this data will be captured in the IoT cloud platform, which is used by us, ThinkSpeak open source cloud platform. And these are key findings. The first figure, figure 6, shows that interfacing firmware with hardware for final testing. And figure 7 shows the RGB LED lights to be deactivated. And the figure 8 shows deactivating the RGB LED lights. And this is the ThinkSpeak IoT cloud platform for light intensity threshold values displayed.
Yes,
and
you have 2 minutes to conclude, please.
Okay, sir. And this is the trial 1 and trial 2 and trial 3 workout data shown on the cloud platform. So coming to the conclusion part, the work involves interface on of embedded C software with the previously discussed hardware. IoT ThinkSpeak was also utilized for data acquisition and cloud storages. Following the design and development, the software was successfully tested using pre-programmed drills. So future scope involves the sensing range can be increased even more, and it can be made waterproof, and much more. One exercise drills can be made for user to make it even more interesting, and can reduce the limit of light colors, because human brain also has some limitation to in order to deactivate in instantaneous deactivation. So thank you everyone.
Thank you very much, sir, for your presentation. Do we have any question for this presentation?
I don't think so, any questions. Ustad, we can go for next presenter.
Thank you, Harsh, for your presentation.
Oh, okay, thank you everyone. Thank you.
Next presenter.
Able to see my screen, sir?
Yeah, we
yes,
can see. Please go ahead.
Good afternoon, everyone. My name is Nischal, PG student at National Institute of Engineering, Mysore, Karnataka, India. I am going to present a paper titled The Design and Development and Simulation of a Quadruped Robot for Engineering Application. This paper is carried under the guidance of Mr. Vikram.
Nischal, don't go on the detail. There's enough. Everything is there. You have to highlight that's all.
Okay, sir. Coming to the introduction part, autonomous robots can be roughly classified into 2 parts: mobile robots and stationary robots. In mobile robots, it comes the legged robot. Legged robot can be used in certain planetary surfaces, building and disaster relief places, where the majority of the situation where wheeled and tracked robots cannot be able to achieve. Where there we can implement the legged robots. In legged robots, there are based on the number of legs, the stability of the robot can be achieved. The advantage of legged robot is that they can maintain the balance and continue walking even with one leg, which improves failure tolerance. The disadvantages associated with legged robots is that they need sophisticated mechanical design as well as complicated control algorithm to achieve that. Coming to the quadruped robot, quadruped robot has a stable, statically stable structure. Coming to my abstract of my project, here I am going to, in mobile robots has become highly popular in recent decades. I am designing a quadruped robot based on that application. Legged robots are a category of mobile robots can walk over obstacles and navigate unstructured terrain better than wheeled and tracked robots. The focus is on design, simulation, electronic hardware, and software testing of the quadruped robot, which is based on our own design. The selection and integration of electronics and hardware plays a vital role in the development of a quadruped robot. The direct inverse and kinematics
Sorry
model.
for disturbing. Hello.
Yes, sir. Yes, sir.
You're reading from the slide. Suppose the slide has 6 sentences. You just tell only 2 sentences, which is important.
Okay.
Don't go on telling everything because it takes a lot of time wasted. Please go ahead.
Okay, sir. The testing and
keywords not necessary. Go to the next slide.
Okay, sir. Coming to the research.
Highlight. What is the objective? Highlight. That's all. Because everybody can read that one.
The objective is that to develop a quadruped robot and to select, program, and simulate the robot to provide locomotion and analysis the hardware components associated with it for the design.
Yes, that's correct.
Coming to the design approach of the robot, here for the initial design we have designed using Fusion 360. The CAD design is carried on in Fusion 360. Kinematic and dynamic modeling is carried out using the equations. Dynamic simulation is carried out in Unity, and FME analysis. This is the control pattern where we can design approach is carried for multiple iteration for design of a robot. Next, coming to the specification of the robot, this is the design we have carried and we have built using a 3D printed model. The quadruped robot is developed for a load carrying and civilian purpose. According to the suggested viewpoint design, the robot can carry a load up to 5 kgs. The robot has 4 legs, each with a 3 degrees of freedom for a total of 12 degrees of freedom. It can carry, each leg carries each leg has a weight of 0.5 kg. It is 3D printed with a poly lactic acid material, and the torque associated with the motor is 7 Newton-meter. Coming to the characteristics, as I told, the mass of the overall mass is 3 kgs. The motor weight is 0.7 kgs. As you can see, the length, width, and other things.
Go to the next slide because everything is clear.
Okay, sir. Quadruped, coming to the quadruped robot, kinematic, dynamic, and static analysis, as the legs has to be stabilized. The static stability can be achieved, but the dynamic stability cannot be achieved easily. That is the main drawback of legged robots. So we have to implement forward kinematics and inverse kinematics to move the robot in for the movement purpose for trajectory and gait analysis. Coming to the DH parameters, for a basic design, DH parameters plays a vital role as it is 4 parameters associated with a particular convention for attaching reference frame to the links of a spatial kinematic chains. This is the DH parameter link. That is the 4 parameters are link length, link twist, link offset, and joint angle, which is considered in this table for the robot. Coming to the forward kinematics refers to the compute the position of end effector from a specified value for the joint parameters. This is from the leg tip to the cox of the robot, where we have to consider the position and orientation of the matrix. These are the calculation transformation matrix from one joint to another joint. The final equations are represented in Px, Py, Pz form. Coming to the inverse kinematics, that is also required for the locomotion for cultural algorithm generation and everything. These from goal position to the joint angles, there are many approaches and drawback where we have to overcome it to achieve the locomotion. There are two approaches, analytical and iterative. We have used analytic approach for dynamic calculations, where the motor is calculation, the motor torque and everything is calculated using the equations. The Lagrange technique is used, where it is an analytical technique for calculating the difference between kinematic and potential energy by using an end operator, which is referred from an IIT textbook, SK Saha. Coming to the selection of hardware components, it is crucial in robotics because if overweight and other things is there, the robot may fail. Coming to the, we have used a dynamical motor based on the torque values. The dynamical motor, which has a PID control system engraved, and it has a very less weight, which is applicable for robotic applications.
You have only 2 minutes time. Please conclude the things.
Yes, sir. We have used the dynamical controller, and these are the hardware components which are used in the robot. Coming to the programming part, the control algorithm used in this system is error, position error, and controlled through the scripted code with the help of absolute encoder integrated in the 12 dynamical motors. The position error are controlled with the PID controller script and joint manipulator script. With the help of inverse kinematics and codings, the quadruped movement can be achieved, as you can see in the figure. Coming to the programming part, the program initially the initialization for the rapid execution, the initial values of the variables.
Sir, I think better you discuss the results, which are the major things, and then conclude.
Okay, sir.
This is yours.
Coming to the okay, sir, I will conclude it. Coming to the Unity simulation part, where we have tested the robot before building. These are the approaches. We have used a C# programming language and animation rigging and everything. You can see the simulation part here. It's around 10 seconds. Coming to the conclusion part, the focus has been towards
sentences. That's all. Don't go to everything in the conclusion. Tell me highlight of the conclusion.
Yes, sir. The required model is achieved by using the design approach, design modeling and simulation, which has been done, and it has been tested, and it is working fine, sir. That's all.
Okay. It's a good present. That video really liked it here. The way you have shown for 10 seconds. It's a very good video.
Thank you, sir. Thank you, sir.
It's a good presentation. We'll go to next presenter.